In 1994, a physicist named Miguel Alcubierre published a paper that should have been impossible. It was titled, "The Warp Drive, Hyperfast Travel Within General Relativity." And what it described was a mechanism, a theoretically valid mechanism, within Einstein's own equations, that would allow a spacecraft to travel faster than light without violating a single law of physics. The physics community did not dismiss it. They did not laugh. They argued about it. They still are. Because Alcubierre had found something genuinely strange, a loophole in spacetime. A way to bend the universe around a ship rather than move the ship through the universe. Star Trek called it warp drive. Physicists call it the Alcubierre metric. And the question of whether it could ever actually work is one of the most fascinating conversations in modern theoretical physics. Today on Nexus Verge, we find out exactly how close science fiction is to science fact. First, let's clear up a common misconception. Warp drive, the Alcubierre version, does not involve a ship moving faster than light. It involves the ship not moving at all, while the space around it does. Picture it like this: you are standing on a carpet. Instead of walking to the other end of the room, you fold the carpet so that the other end comes to you. You haven't moved. The carpet has. The ship sits inside a bubble of flat spacetime. Behind it, space expands. In front of it, space contracts. The net effect, the bubble, and the ship inside it, moves at effectively superluminal speed relative to outside observers. But locally, inside the bubble, nothing is moving faster than light. Einstein's speed limit is never actually broken. It's bypassed. This is precisely what Star Trek described, decades before Alcubierre wrote his paper. The warp field. The subspace bubble. The metric of spacetime itself being manipulated by the ship's engines. Gene Roddenberry's writers intuited something that a real physicist would later formalize mathematically. That is not a coincidence, it reflects how often science fiction and theoretical physics are asking the same questions from opposite ends. Here is where the elegance of the idea meets the brutality of physics. The Alcubierre metric requires something called exotic matter, a form of matter with negative energy density. Not antimatter. Not dark matter. Something stranger, matter that has less than zero energy. As far as we know, this does not exist in any usable quantity. Small quantum effects suggest something like it may flicker in and out of existence at the Planck scale, but harnessing it in the amounts the original Alcubierre metric required, which was roughly equivalent to the mass energy of the planet Jupiter, converted entirely into exotic matter, is not currently possible. It is not even close to possible. The energy budget alone makes it essentially theoretical. The second problem is the horizon problem. Once a warp bubble forms around a ship, the front edge of that bubble is causally disconnected from the crew inside. In plain English, the ship cannot steer. You cannot send a signal from inside the bubble to the front of the bubble fast enough to change course, because you would need to travel faster than light to do it, which is precisely the thing the bubble is already doing. You set your destination before you leave, and you are committed. You cannot course correct mid-warp. Third problem. When the bubble collapses at the destination, all the high-energy particles it has been accumulating at its front edge are released simultaneously. Depending on the distance traveled, this burst could be energetic enough to sterilize the destination. You arrive at a planet and vaporize it in the process. This is what physicists call a significant engineering challenge. Here is the part that most people don't know, and it is genuinely exciting. In 2012, Physicist Harold White at NASA's Johnson Space Center announced he had found a modification to the Alcubierre metric that reduced the exotic matter requirement by several orders of magnitude. By changing the shape of the warp bubble from a simple sphere to something more like a torus, a donut shape, and oscillating the bubble's intensity, the energy requirement dropped dramatically. Not to achievable levels. Not yet. But from mass of Jupiter to something at least theoretically discussable. NASA actually ran an experimental program called the Advanced Propulsion Physics Laboratory, nicknamed EagleWorks, which investigated this and other exotic propulsion concepts. The program was small. The results were inconclusive. The exotic matter problem remains unsolved. But the fact that a serious physicist at NASA was working on this with actual laboratory infrastructure is not nothing. It is the universe of difference between "this is impossible" and "this is very hard and we don't know how yet." Star Trek got the core concept of warp drive strikingly right, warping spacetime rather than accelerating through it. The idea that warp travel requires enormous controlled energy is absolutely correct. What it got wrong, the steering. The instantaneous course corrections. The complete absence of the particle accumulation problem. And the warp factor system itself. In the original series, Warp 10 is infinite speed, which creates logical paradoxes the writers quietly ignored for most of the show's run. Real faster-than-light travel, if it ever becomes possible, will almost certainly be committed, destination-locked, and deeply weird in ways that would make for great television and terrible tactical flexibility. Warp drive is not impossible. That is the honest answer. It is extraordinarily difficult, requires physics we do not yet understand, and rests on the existence of a form of matter we have never observed in usable quantities. But it does not violate known physics. It lives in the space between what we know and what we have not yet discovered, which is exactly where every great technology in human history has lived before someone figured it out. The Wright brothers were impossible until 1903. The atomic bomb was theoretical until 1945. The internet was science fiction until it wasn't. I am not predicting warp drive in our lifetimes. But I am absolutely not ruling it out in the next 10,000 years. Next week, the AI that science fiction has been warning us about for 70 years. HAL 9000, Skynet, and the real AI safety debate. How close are we actually to the machines the movies taught us to fear? Subscribe, I'll see you Friday.